Philips Aachen Super D60, 1939–1940. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is also welcome and appreciated. This radio comes from Italy. I received it as a gift from a gentle stranger. She inherited this radio from her aunt, but it is not known if there have been other owners before her. According to the original Philips customer service guide, this radio was planned to be in production during the period between 1939 and 1940. But inside the radio there is an important component with a date printed on it, the 22nd of April 1942. So it is reasonable to assume that the actual production was prolonged for a few more years. Hidden inside the chassis there was a small cardboard tag which should have mentioned the exact day of birth of this unit, but either it was not written or it just faded completely. Anyhow, this radio has been built during wartime in Aachen, a city of Germany. What you see is a short clip filmed the 15th of October 1944 in Aachen by the U.S. forces and released in the public domain, as reported on Wikipedia page Battle of Aachen. A small fire stamp at the bottom of the cabinet reminds of those hard years for Europe and the entire world. Considering what was going to happen in Germany after a couple of years, it is reasonable to assume that this unit arrived immediately in Italy. Unfortunately, the circumstances are not known. This radio must have had a long working life accompanied by regular maintenance. Externally, it can be noticed that the front knobs are not original. The red Philips emblem between them is missing. A metal decoration that should appear in the middle of the grille cloth is lost, and the same is for the small bottom panel. Inside and under the cabinet appear various signatures, testifying the intervention of different people for servicing the radio. It is clearly visible that the volume potentiometer was opened, and that the repair person was Italian, because they carved the initials of the wire colors according to Italian color names. Also, the tone potentiometer seems to have received attention because of a red notation on its body. The resistor between the two electrolytic filter capacitors must have been replaced. The first intermediate frequency transformer CAN has been opened. Some adaptation has been made to the radio frequency section to bypass the initial input tuning stage. The mustard capacitor says that this adaptation was made in the 1970s. The audio transformer has been partly rewound. Other details have been observed, telling that servicing this radio was a struggle. Like this B+ connection floating on air, like this abandoned open wire, like these components that have been left by the factory ready to short, like these unsoldered components that cannot be reached with a soldering iron without dismantling the area completely. It is reasonable to assume that the last repair or the last repair attempt has been made in 1975, like the year written under the case shows. The radio arrived with the dial pointer not working due to a piece of string that was torn. Very likely the radio has still been used for a while without seeing the movement of the dial pointer. Philips was producing in Germany the models Aachen Super D, aiming for better reception quality and advanced aesthetic design. In particular, some of these, instead of the usual dial cord, have a flexible empty cable containing a steel wire like those of bicycle brakes. The models D4849, D5253, D5758 have in common a fold-down dial, which in fact could not be operated by a traditional dial cord. However, the models D60 and D61 have a fixed dial, so it is unclear why Philips decided to use the same steel wire technology for their dials, considering the useless trouble that would have implied in the production process, not to mention for servicing these radio models. There is, however, a disturbing detail on the design of the Model D60 under restoration. The variable capacitor pulley, instead of being easily accessible at the edge of the chassis, it is exactly in the middle of it, surrounded by large and tall components, making it impossible to accessing it without removing those components first, which would be usually out of the question. None of the other mentioned models share this design. The dial of the D60 has yet another detail to make things a little more difficult. The band indicator appearing at the bottom of the dial window is pulled by another steel wire. Removing and reinstalling the front panel of the radio requires extracting and inserting that indicator with a seriously challenging procedure, having to move around heavy and delicate components with the risk of damaging them. During the restoration, this procedure had to be attempted several times. All the other mentioned models have a chassis made of a single piece, while this radio has a chassis with some extension for the power transformer and the audio transformer as well. Anyhow, all that using a very thick iron sheet of 2 millimeters. With such a design, the main chassis has very little space for the components that usually should hide under it. In fact, under the chassis, the components in the audio section were installed on layers following a precise mounting procedure, but making it extremely difficult, if not impossible at all, servicing the radio. The area was so busy that some of those components had to be installed by the factory also on top of the chassis, and some other flying around between those and the audio transformer. Last but not least, the Magic Eye is part of the amplification process. It is precisely the preamplifier between the end of the intermediate frequency chain and the final amplifier tube. That means that it must be connected while testing the radio chassis, and that its connections are very sensitive to noise. Nevertheless, it has been located on top of the front panel using wires about 30 or 40 centimeters long. For those reasons, the Magic Eye preamplifier and other components had to be connected using shielded cable, which at that time was particularly hard and thick, more difficult to install, and surely not cheap. I love this radio. I appreciate its quality, the aesthetics, the reception, and other details, but all the above circumstances remain a mystery to me. For this radio model, there are at least 3 schematic diagrams published by authoritative sources, but they don't match perfectly. The problem is that the shields of the shielded cables are not always connected to the chassis ground. They correspond sometimes to elevated grounds. Redrawing the schematic diagram, while verifying with the unit under restoration, it turned out that only the one published from Philips in its customer service guide is reliable. What you see is the redrawn schematic diagram with some additional information. It is clearly impossible to visualize all the details for the insufficient resolution of this video. However, the written documentation that comes along with my videos contains a better detailed copy of it, and if you are interested, you are invited to check the links appearing in the description. Please notice that the connection layout of the band selector switch of the unit under restoration is different from the one that appears in the above-mentioned schematics, even though it operates in the same way. I don't know if the same band selector switch was used in all D60 models, or if it was changed at a certain point. In opposition to the physical design described above, the schematics show a very sophisticated electronic arrangement. For medium and long wave reception, there is a double input tuning section. In this area, L32, C53 and C43 are used to suppress the frequency of 128 kHz used by the intermediate frequency stages. The coil composed by L13 and L14 is used to balance the two input tuning stages in the absence of a preamplifier tube. The tube responsible for the detection is the final amplifier. Usually this is a function incorporated in the audio preamplifier tube, but in this case, in which the Magic Eye is also doing the preamplification job, the detection had to be assigned to a different tube. It should be observed the fairly complicated negative feedback circuit, which requires an ad hoc audio transformer. Please notice that the audio ground is elevated compared to the chassis ground, and it corresponds to one of these negative feedback lines. For convenience, in the rewritten schematic diagram, the four negative feedback lines have been labeled from NF1 to NF4. Inside the unit under restoration, capacitor C12 was connected differently, very likely by the factory, and an additional capacitor of 4.7 nanofarad was added in the 70s, a mustard-style capacitor, to bypass the first tuning section. Also, the second electrolytic filter capacitor had a lower value than what was required by the schematics, but that was also clearly done by the factory, considering the peculiar type of electrolytics used by Philips at that time. Every electronic restoration requires making choices, trying to balance the desire of keeping the device as original as possible, and the goal of bringing it back to life, reliably and safely. Unfortunately, European radios of that time were built under the chassis in an awful way, often soldering components together without a dedicated tag strip and without letting enough space. From this point of view, this radio is particularly challenging because the space is tight and there is no way of putting enough tag strips, even considering the usage of new small components. This radio is going to be fully dismantled, verifying and writing down the actual connections. As usual, all these drawings are available in the written documentation with better resolution. Then the radio will be rebuilt using small perforated boards when necessary to organize the components in a more sensible and effective way. I will try to make these little boards as less conspicuous as possible, and I hope that the donor of this radio will also be satisfied with the result. After stripping the chassis of the components that it had underneath, it was the time to think about the components on top. I decided to hide new capacitors inside the cans of the two old filter capacitors, even though now I would suggest something different that will be explained later. If one wants to open these Philips capacitors, there is a cap that should be removed carefully, and then the top part can be easily cut. There is a liquid inside the cans that should be disposed of, and then it would be sufficient to drill a single hole at the bottom to get rid of the metal grid that these capacitors have inside. Later, once one has put new capacitors in the cans, the cap can be used to close the cans without harming the aesthetics. While the two filter cans were off the chassis, I decided to remove the variable capacitor for washing it properly, and also to replace the cord that moves this pulley, because I judged it too old and not reliable anymore. However, if you are restoring the same radio model, please think twice before doing what I did. If you think that the cord is still in good condition, it is probably safer to let it stay there as it is. Please notice that it could be possible to remove the pulley from the variable capacitor without removing the cord, but then one would have to remember exactly how the pulley was oriented in comparison to the position of the capacitor blades. The original cord was 425 mm long. It was made of natural jute of about 1.5 mm diameter, and it was wrapped in 4 turns on the tuning shaft under the chassis. Please notice that there is a small hook on the pulley which is used to connect the steel wire that controls the remote dial indicator. I decided to use a thicker nylon cord because this cord runs under the chassis where there is the chance to touch it inadvertently with a soldering iron while servicing the unit. However, this type of nylon cord can be stretched over time, which probably is not the case for a good jute cord. Anyhow, if one replaces this cord, they must wait some days before mounting the filter capacitor cans in front of the pulley, because very likely at that time the tension of the cord must be increased. This is the reason why I was suggesting not to refill the filter capacitors, so that the cans could be placed on the chassis without connecting them, letting them easily removable when needed. Removing the coil cans from the chassis is not recommended at all, unless they are damaged and needing to be opened. These cans are held on the chassis surface, bending 2 small but extremely hard flaps of iron sheet. To remove one of these cans, one has to bend up these 2 small flaps, which is very difficult, without damaging the aluminum of the can. Putting the can back in place requires one to bend down those flaps, which is even more difficult. Even though in the schematics it is not explicitly represented, inside the intermediate frequency transformers in parallel with the trimmer capacitor, there must be a fixed capacitor of about 68 picofarad. I was concerned that it could have been a deteriorated mica capacitor, like all the other mica caps that were installed in this unit. But I found that the capacitor contained in the intermediate frequency transformers is a tubular ceramic type, with no reasons for concern. However, I took a video of the process of removing the first IF can, extracting its content, and replacing the cap wire. If you don't need this piece of information, this clip is just long and boring, but you may always skip to the next section if you prefer. Inside this radio, there were only a few tag strips for connecting components. Due to their peculiar arrangement, I would rather call them post strips, because they were mostly vertically planted in holes of the chassis and squished into them to hold them in place. But they were not held firmly, and they could tilt some degrees if they were just gently pushed, and with just slightly more energy they could get loose. Please notice that under the chassis there were only 7 of them, connecting too many components. I decided to remove these post strips because they were not in a good shape, and because I could not reproduce the same messy component arrangement adopted by the factory. The chassis of this radio model is very thick and extremely hard. Soldering on it requires a very powerful soldering iron. To make the connection to this chassis easier, it would be appropriate to build a simple network made of copper wire, so that later a low-power soldering iron could be sufficient to do the job. After that, it is time to organize the power supply, so that all the filaments are connected and the B+ is available. By the way, it is important to keep in mind that the trimmer capacitors C23 and C27 are connected to B+, and particular care should be taken to avoid touching them while testing the radio and to use insulated tools for the alignment. Now that there is power, the first part of the radio could be rebuilt, reaching the first intermediate frequency transformer. In this area, there is the balancing coil composed by L13 and L14, which originally was connected without a dedicated place inside the chassis, but just attached to the terminals of C10 and C11. That made the coil particularly vulnerable, and in fact its terminal broke, damaging the delicate wire of both sides, L13 and L14. Therefore, repairing the coil required also to make a safe place for it, and a small board has been used for the purpose, incorporating also C7, C10, and C11 on it. Most of the original capacitors are changed. In particular, all the deteriorated mica capacitors are replaced with NP0s. Because they are surface mount style capacitors, some adaptation is required to add some terminals to them. However, the original capacitors C7, C8, and C12, which are ceramic from the factory, have been kept. The trimmer capacitor C19 has been replaced. All the resistors have been replaced, including the one hiding inside the cap socket of the EK2 tube. The automatic gain control line is temporarily connected to the chassis ground, which would correspond to obtaining the maximum amplification. Safety capacitors are used to isolate both ends of the antenna input. Finally, the first test is made connecting the antenna and using only an oscilloscope to see if there is some signal coming out from the first IF transformer. And luckily some signals are received from all bands. After having tested the tuning and oscillator section, the rebuilding process continues up to the second IF transformer. At the moment, there is still no automatic gain control, but the signal coming out from the second IF transformer can be listened to with a signal tracer. Before installing the Magic Eye and preamplifier tube, it is still possible to reach the detector stage, installing some more components. At the moment, Instead of actually installing the detector and final amplifier tube, a couple of signal diodes are installed in parallel on the tube socket. At this stage, the automatic gain control is now operational, and the signal coming out from the second IF transformer, amplified by a signal tracer, is more satisfactory.
Однако на протяжении
At this point begins the difficult part of rebuilding the audio frequency section of this radio, which includes the complicated negative feedback network already mentioned. The plan is to use small boards to arrange components in a sensible way. However, the first board of this section is not meant to host components, but its purpose is to be the hub for the connections between the audio transformer and the rest of the radio. In fact, the audio transformer of this unit is in precarious condition, and its terminals could not stand any kind of stress anymore. Between these soldering posts on the board, some extra space is saved to avoid creating short circuits by soldering on them. In fact, some high voltage is going to be used on these small boards. The problem is that while soldering on the prepared posts, some very small residues of solder might reach the solder pads around the unused holes anyway. Therefore, I judged it safer to drill those unused holes to remove any trace of conductive pad around them. I decided to divide the middle audio section between the last intermediate frequency transformer and the final amplifier tube in two groups of components, one responsible for driving the Magic Eye and preamplifier tube, the other one responsible for the intricate negative feedback network. I placed the first group on a small board, residing on top of the chassis exactly where previously some components were sitting for the same purpose. I placed the second group on another board located under the chassis, and I considered this one as the main board. I labeled the connections on the boards with letters, and later I decided on a criterion for the choice of color to use for the wires connecting them. In practice, I used as a reference the main board that would have been located under the chassis, following this type of color code for every wire starting from it. This radio uses metric type screws, in particular size M3, M4, and M5. In some cases the screws were no longer original and not matching. In some others they have been damaged or they had the tendency to remain stuck. Where possible, I changed the screws and the nuts with stainless steel equivalents so that they are now all matching. I used Phillips head screws for safety. The intermediate frequency transformers should be aligned using a modulated signal at 128 kHz, applied at the C4 variable capacitor section, while the variable capacitor is left in the position corresponding to the lower frequency. However, before regulating the trimmer capacitors involved, two damping resistors of 22 kΩ should be temporarily connected. The first time, the two resistors should be connected across C24 and C27 respectively to align C23 and C30 for the maximum output signal. The second time, the two resistors should be connected across C23 and C30 to align C24 and C27 for the maximum output signal. Then the resistors should be removed and the trimmer capacitors should be sealed. While the signal generator is still configured for a modulated signal of 128 kHz, it should be connected to the antenna input to correctly set the blocking circuit, trimming C43 for the lowest possible output signal. To do that, the band selector should be in the long wave position and the variable capacitor should be put to the position corresponding to the lowest possible frequency. Then, it is necessary to align the oscillator circuit with the input tuning sections. Initially, this is done for the medium wave band, selecting it with the band selector switch. The variable capacitor should be fully opened, but putting something that would stop it at about 15 degrees before reaching the end of stroke limit. Then a modulated signal of 1520 kHz should be applied to the antenna input, and the trimmer capacitors C6, C9, and C17 should be regulated to obtain the maximum output signal. Please notice that in some misalignment conditions, the radio could be induced into oscillating in unwanted manners, including audible sound and high frequency, that would make the output completely silent. So the accuracy of this particular alignment phase is very important. The alignment for the long wave reception requires regulating C19, which originally was a wire capacitor, like the picture shows. First of all, the oscillator should be silenced using a 100 nanofarad capacitor between the first grid of the converter tube and the chassis ground. The first tube should then operate only as an amplifier, and a signal should be collected at its plate to be detected with a signal tracer. A modulated signal of 407 kHz should be fed to the antenna input, and the variable capacitor should be turned to tune into this signal for the maximum output from the signal tracer. Then, the signal tracer and the capacitor that was used to short-circuit the oscillator should be removed without touching the variable capacitor, and C19 should be regulated to obtain the maximum output signal from the radio. The front panel had a dirty, fragile, and torn grill cloth. I looked at what I had in my box of scraps of cloth. and I finally chose the pattern that is visible in this picture. It is significantly different from the original, but there are also decorative parts that are missing on this unit, and even the knobs are different, not matching the original look of the radio anymore. So those flowers could fill that empty space left at the side of the dial face. Therefore, I stripped the original grill cloth and glued a piece of that fabric on the wood panel. If in the end it does not look good, that could be changed. Mounting the dial on this panel also requires replacing the small cord that is meant to keep the dial indicator pulley in tension. For this purpose, some strong fishing wire is used, which works fairly well. However, mounting the panel to the chassis is more difficult than it could be expected because there is the band indicator that should slide inside the dial window. This is the original wire, which has been replaced with strong fishing wire. However, the fishing wire used in the way that is visible in the picture tends to easily disengage from the pointer while trying to slide it into the dial window. With hindsight, it is probably advisable to keep the original steel wire until it is completely broken before trying to install any type of replacement for it. Here is the panel finally mounted. It is now possible to see the full movement of the dial cords and cable. The dial glass has not been mentioned yet. One should know that by now the writings on the dial glass are just dry powder that would be wiped out simply touching them. So cleaning the glass requires extreme care, avoiding getting in touch with those writings. It should be noticed that there are residues of white paint along the edges of the glass, which was likely used to reflect the faint glow of the dial light. During the time in which this radio has been designed and built, it was fairly safe, considering that there is an isolation power transformer and a fuse was included too. However, nowadays some extra care is in order. First of all, both ends of the antenna and phono inputs have been isolated with safety capacitors. There are now two modern fuse holders to protect both input power lines. The chassis is now connected to the external ground, but in order to do so, the power connector had to be rearranged. Also, the special power socket on the power cord had to be rewired accordingly, but in this case, some better insulation was required, taking care also to connect the small metal plate to the external ground. The original insulator is totally unsafe. What will be put between the contacts and the metal plate is a piece of large heat shrink pipe instead. The external ground is connected to the metal plate using solder. When the radio arrived, the cabinet had a still active woodworm, and consequently an anti-woodworm treatment was immediately applied. Considering that the cabinet was still in a relatively good shape, I decided to keep it as it is, using only some red oil for reviving and polishing it. I finally added a replacement for the missing bottom panel. It is just a piece of corrugated plastic. It would probably be better to use a metal plate here, but I prefer something that is safer instead. It is now time for a last view of the chassis before inserting it inside the cabinet. Inserting the chassis inside the cabinet is not so straightforward because the front panel must enter slightly tilted. Finally, I want to attach inside the cabinet the list of the known owners so far. There is also space for the names of those that will have this radio after me. Considering that before the restoration, this radio was almost completely original, I think that it is important to keep track in this documentation of what has been removed or replaced. In particular, I kept an accurate record of the components while I was dismantling the radio, and that helped me to double or triple check what I was doing. I am keeping the old components and the old hardware that remains after each restoration, although I think that sooner or later I will dispose of the old capacitors unless they can be refitted. The Philips Akin Super D60 radio is ready. Shortwave band.
Realizzaziści otto spojrzeniec januari.
Attract a lot of people. Really, a survey on a certain point, people go.
The intermediate frequency for this radio is only 128 kHz, which is too low to prevent image interferences. It could be noticed that the stronger stations seem to appear in various different frequencies.
Речь идет о непростой истории.
На те, щоб зберегти нашу
1986 года, когда Мельхиор
These are things that are done from outside.
народно-освободительной армии Китая, участвовавшего в спасательных работах. That you can't come up with any price hikes despite increasing the происходит трагедия. During the May Day holiday on mainland.
I'm Kenny Benneret.
In the artwork, etc. But literally, one picture on the wall, and
In the area there are many FM broadcast stations. The distorted signals are interferences received from those powerful local transmissions. medium wave band.
Indeed. To continue.
Long wave band. Unfortunately, at least in this area, it is extremely rare to be able to receive any signal from the long wave band, and this radio is no exception. If you would like to contribute to this project, donating old electronics equipment or old radios in whatever condition they might be, provided that you do not feel any attachment, that could be helpful for my next restoration documentation and video production.